Hi everyone, my name is Ali Al-Bihadili and my project is optimization of injection brine composition and the impact of geochemical reactivity. My supervisors are Professor Eric McKay and Professor Ken Sorby. Background here, what the meaning of a scale problem? It is the scale problem. It is very common problem when in the oil field use the water injection to maintain reservoir pressure or even the seawater or produced water re-injection applied. Difference between injection and formation water, uh, it will be causes the scale problem. The common inorganic scale problem, it is carbonate scale problem or sulphate scale. Carbonate scale, it is precipitated due to the difference or the change in pressure, temperature or pH, and the sulphate scale due to the mixing of incompatible brines. Objective of my study, or why study the major effect on scale problem or scale behavior, for example temperature, pH, brine composition, CO2 availability in the system, and geochemical reaction. Discover impact of full sulfate and low sulfate. Study change in sulfate scale behavior, example barite, gypsum. Reaction with carbonate minerals also very important, for example in calcite or dolomite. The reasons are it is to maximize the oil recovery, decrease the scale problems and their impact, improve brine injection to minimize the cost and footprint. Research question of my study: when is best time to treat injection brine? For how long and targeting what composition? Methodology: CMG GIM numerical simulator and CMG CMOS optimizer are used to model the effect of geochemical reaction in the reservoir on the scaling risk. Geochemical reactions, for example, including the sulfate and carbonate reaction in situ, impact of availability of CO2, understand to which extent brine composition may be affected, calculate the saturation ratio and rate of deposition rate. Reservoir behavior, water flooding system, change in bubble point pressure and support. For example, compare single porosity and fractured and what the effect of of scale problem on the porosity of the reservoir. Finally, calculate the impact on oil recovery and optimized injection design. Here the composition of injection and formation water. Here we can see the injection water in full sulfate and low sulfate. In full sulfate we can see the the SO4 concentration about 3000 milligram per liter, and in low sulfate the concentration of SO4 is about 40 milligram per liter. Here the formation composition, you can see the barium is about 700. Also SO4 is very low concentration in formation water. Here you can see the mineralogy of or mineral composition of this field. It is carbonate and dolomite. This plot we can see the geochemical reaction in and around producer well. Plot show the here in barium and SO4 behavior. We can see the sharp drop in concentration of barium in low sulfate and full sulfate around year 7 because the water break through. Also the concentration of calcium drop from the about 1700 at the same time at year 7 because again because the water break through due to also and again and also because the anhydrite and dolomite precipitation. This plot shows us the behavior of anhydrite and barite around the producer well in the formation. You can see here in full sulfate seawater, the barite precipitation higher than low sulfate, about 2700 kilogram versus 370 because the high concentration of SO4. Here, this plot shows us the barium, the barite precipitation rate and saturation ratio. And we can see the maximum deposition rate about 10 kg per day. After that, to the end of the simulation, still around 4 kg per day. Here we can see the deposition rate. It is higher than saturation rate, saturation ratio, because the deposition rate depending on saturation ratio and water rate. Or here, this plot geochemical show us the geochemical reactions around injector wells. We have two injector wells, well I1 and I2. Around well I1, anhydrite deposition occurs in full sulphate and isothermal only, with maximum deposition rate about 80 ton due to the high temperature. In I1, again, temperature decreases from 1037.36 to about 20. Around while in well I2, we can see the temperature drop to just around here about 110. See, this is not very low compared in well I1 due to the injection rate in I2 here is lower than I1 also, and the block location in I2 here in oil lake close to hot overburden rocks. Thank you very much, and please if you have any question let me know. Thank you very much.